Hello, today we are going to talk about acid rain. Acid rain is rain that has some harmful chemicals in it, which makes it more acidic than regular rain. But acid rain doesn't just mean rain, it can also include snow, hail, and even dew, meaning water on plants in the morning. All of these forms are called acid precipitation. When we talk about acid rain, we also need to think about things like gases and tiny particles in the air that can fall to the ground and mix with plants, soil, and buildings. These can also be harmful, even if they don't fall as rain or snow. The main chemicals that cause acid rain come from two gases, nitrogen oxides and sulfur oxides. These gases mix in the air and turn into acids, like nitric acid and sulfuric acid. These acids then fall with the rain, snow, or other types of precipitation. Now let's take a look at how acid rain forms. Acid rain forms through a combination of chemical processes that involve both gaseous pollutants and atmospheric reactions. The first mechanism is precipitation or wet scavenging, where pollutants like sulfur dioxide and nitrogen oxides are released into the atmosphere from sources such as factories, cars, and power plants. These gases can dissolve into cloud droplets, forming weak acids like sulfuric acid and nitric acid. When clouds condense and release precipitation, these acids are carried to the Earth's surface in the form of rain, snow, or fog, bringing down both dissolved gases and acid particles already suspended in the air. A second process, dry deposition, occurs when acid gases and fine acid particles settle directly onto surfaces without the need for rain. These particles can accumulate on soil, plants, buildings, and bodies of water, leading to gradual environmental damage. This form of deposition can have immediate harmful effects even in the absence of precipitation. The final mechanism involves complex chemical reactions that occur in the atmosphere. For example, nitrogen oxides emitted from vehicles and industrial sources can react with other compounds, like ozone in the air, producing nitric acid. Similarly, sulfur dioxide undergoes oxidation reactions in the atmosphere, leading to the formation of sulfuric acid. These chemical changes result in the creation of acidic particles and droplets, which then fall to the ground through precipitation or dry deposition. However, there is no need to worry, since we can always find ways to help reduce the problem. Addressing acid rain requires targeted strategies to reduce emissions of sulfur dioxide and nitrogen oxides, the primary contributors. These gases are released mainly through the burning of fossil fuels in power plants, vehicles, and industrial processes. Mitigation starts with transitioning to cleaner energy sources such as wind, solar, and nuclear power, which produce no emissions during operation. Enhancing fuel standards and promoting electric or hybrid vehicles further curbs nitrogen oxides emissions from transportation. Industries play a critical role by adopting technologies like flue gas desulfurization systems to capture sulfur dioxide before it escapes into the atmosphere. Improved efficiency in combustion processes and the use of low-sulfur fuels can also limit pollution. Additionally, implementing regulatory frameworks like emissions trading systems provides economic incentives for companies to reduce their output of harmful gases. Reforestation and restoration of wetlands offer natural solutions by absorbing carbon dioxide and improving the resilience of ecosystems impacted by acid rain. Lastly, international cooperation is crucial, as air pollution can travel across borders. Through a combination of cleaner energy, technological innovations, and strict enforcement of environmental laws, we can effectively reduce the sources of acid rain while promoting global environmental health. We should also mention that in addition to human activities, volcanoes can also release sulfur dioxide naturally. Lightning can create nitrogen oxides too. When these gases mix with water in the air, they form acids, which then fall to the ground as acid rain, snow, or even dust. So, acid rain is mostly caused by human activities, but nature can also play a role. The more we can reduce pollution from cars and factories, the less acidic oxide gases there will be in the air. Thank you for watching. I hope you find this video helpful.